Students, this lab number 11 is determination of voltage regulation in a radial distribution system. For that, this is the equivalent, this is a circuit diagram, and this diagram we implemented here. There is a 30 volt AC supply. It is connected to a voltmeter, and from there it is connected to a distribution system. Here each lamp here represent, these lamps represent each load, and this small resistance shapes, this is showing the transmission line. So this transmission line, each transmission line represents, actually it is 26 ohm. 26 ohm, it means 156 kilometer length. Total length is 156 kilometer. So it is divided into 6 pieces. So each piece, each area, so as the distance increases, what happens to voltage? This is what we are going to see in the first part of the experiment. So what we have to do is first apply 30 volt AC. Now you can see all loads are on, but see the difference in the light. This difference in light is because of change in voltage, because voltage drop happens throughout the line. Now as a first experiment, we connected this voltmeter here, and we will see the voltage at the first load. At the first load you can see the voltage is 30 because it is at 0 distance. So if the distance is 0, there is no voltage drop. And the second load, if you go to the second load, connect to the second load, now you can see there is a voltage drop. Because of that voltage drop, the voltage is reduced to almost 24 volt. Now going to the next one, it is reduced to 20. Next length it will be 16, then move to like 14, and by the end the last load will be getting around 13 volt only. So this is connected to last load. So this is first part of our experiment. We will see what happens to how the voltage decreases as the length increases. I have recorded all these readings in the table 1. Okay, now we will continue with the part B. Here we are using going to measure the voltage drop across each feeder. Like here we need voltage across each circuit, and its current also we are going to measure, and voltage drop, and finally we are going to calculate voltage regulation. So I have made some changes in the circuit. Now we have a ammeter connected there, and we have 2 voltmeters used. 1 voltmeter for measuring the voltage across the load, and also another meter to measure directly the voltage drop. Okay, the first reading, now we have the voltage measured voltage is coming 24, and the voltage drop is coming 6. Now I have to change the connection. Like current we need now across the second load, so we will connect here. This will be connected over here, and then this connect here. Now you can see the voltage is reduced to 22, and the voltage drop is increased. Like this we will change load the reading across each load, and correspondingly the readings will be measured. Now the third part of this lab is separate feeder. If you use separate feeder for each load connection, you can see now only at a time one lamp is connected. You can see here. Now I will apply 30 volt. Now you can see all other loads are not connected. Only at a time one load is connected. That is, each load is supplied separately, but they are at different distance. Now only one part of the transmission line is connected, and you can see now the voltage is 27 volt, and the current is very little, like less than 0.1, and this reading will be noted. Next, what we have to do is we will supply this load to second feeder directly. Now only second feeder is there, but now you can see the voltage of second feeder is nearly 20 6 less than slightly is 26. Current is slightly almost same because same load, but the transmission line is now 2 divisions. Length is increased. Similarly, we will shift to next location as it is. Now the volt, because the length is increased, voltage drop increased. You can see voltage drop is almost 5 volt and 24 volt is the voltage, and the current is decreased again. Like this, take reading for all loads. This is lab number 11.